Okay, so this brings us to axiom 2. Axiom 2 is the order axiom. And it says if you have 4 points on the same line, then they have an order. And this is actually an axiom that is not true on a sphere. So if you think about having a sphere, and we'll think of the great circle that is the equator, that'll be our line. And if you think of having 4 points on that great circle, those points are not necessarily going to have an order, because if I want to measure the distance from this point, which is the first one I drew, to this point, which is the last one I drew, that shortest path might go around the back. It might go around the other way. And so you can't find an order that works for all of these. So if they're too evenly spaced out on that great circle, if it's more than a half a circle, that's not going to work. You're not going to be able to find an order. So everything after axiom 2 will work on our nice flat piece of paper Euclidean space, but it won't work on a sphere. And what this lets us do is it lets us take 4 points that are on a line and say, all right, I can use my earlier theorems because I can say they have some order. I don't know what order it is now, but all of my theorems work if I just know that there's an order out there. So for theorem 7, I want to change the name of the line AB. And I want to rename that line to be line AC. And I already know that B is on line AC and if C is on AB. But what I want to know is that all of the points on line AB have to be on line AC. So how do I do that? Well, I have to have a way of naming all of the points on line AB. And the way you name all the points is you pick a variable. So X is a variable that is standing for any or all of the points on that extended infinite line. Now, whatever point that is, I've got 4 points, A, B, C, and X, and they are all on the line AB. They're all on the line AB. And so I get to use axiom 2. Axioms are things that you introduce to state important properties of the mathematics you're doing that are not things that you can prove already. Axioms are when you are introducing a new idea that you can't prove without a new assumption. So axiom 2 is my new assumption, and it says those points have to have an order. And if they have an order, then that means that each point, including X is one of those 4 points, lies on the line defined by any 2 of the other 3 points. So A and C are 2 of the other 3 points. So I know that X is on the line AC. That's exactly what we did. That was the whole point of Theorem 6. And if X is on AC, and remember that's standing in for every single point on the line AB, that means that AB is a subset of the line AC. That's the big idea. Theorem 8 is really back to being a corollary again. really doesn't deserve theorem status, because all we're doing is we're switching names around, right? So here we proved that if C is in the segment AB, then AB is a subset of AC. And so what do? We start off with C being in AB. Well, check it out. Back up in Theorem 5, remember I can swap C for the second letter in the name of that line AB. So I can swap the place of C and B. Check. All right. Now I'm going to take this up and I'm going to apply Theorem 7 to it. This point is in this line. That means if this line is a subset of the line that I name using the same first point, and I swap out the name of the second point, naming the line for the element. So I swap out C and B. Check. If AB is a subset of AC and AC is a subset of AB, then they have to be the same set. All right, Theorem 9. This is where it all comes together. I have shown that if I have a point, if I have 3 letters here, C is an element of AB, then I can swap the names, I can change the name, and I have the same line. So what I want to do now is I want to get from AB, and I want to swap out both letters this time to change the name of the line. And so what I do is I first swap out B for C, okay, and then I want to swap out D for A, but I can't swap D for A without writing another corollary, because this just says I can swap with the second point in the name. So I have to use Theorem 1. All right, and now I've got D is an element of that. That was part of my givens. And so I'm going to swap D for A, and I get CD. So just swap one point at a time until I get what I want. And that is the big idea. That's the flow. That's where this is how you get from an idea of having an order to, I can name any line by any pair of points I want to pick.